which just happened there. I have to restart my whole computer, so I apologize for that. So if you did send me a question, I missed it because I was just out for the last like 3 minutes. But hopefully you had some time to do these problems. So we will work through these right now. So B, I want to go from kilometers to centimeters. Again, the logic is I'm going to go from kilometers to meters to centimeters. Start with the train tracks. 515 kilometers. And let's just do the logic without putting any numbers. I'm in kilometers, so I want to cancel kilometers and go to meters. And then once I'm in meters, I want to go to centimeters. So meters on the bottom, centimeters at the top. So just looking at canceling my units, kilometers at the top, kilometers on the bottom, they cancel. Meters at the top, meters on the bottom, they cancel. And I'm left in the unit of centimeters. Now let's put in numbers. From my table, 1 kilometer equals 1,000 meters. So 1 to 1,000. And then 1 centimeter equals 0.01 meters. So 0.01 meters. No, I would not like to do this virus thing right now. Thank you, computer. 0.01 meters is 1 centimeter. Then you take everything at the top, multiply it together. So 515 times 1,000 divided by everything at the bottom, which is 0.01. And you will get 51,500,000 centimeters. In C and D, more or less follow that same logic. And I made C and D relatively more simple because here we're just going from seconds to milliseconds and seconds to kiloseconds. And this shows you the power of the metric system in that we're in a unit of time now. A and B were a unit of length. Now we're in a unit of time, but the conversions are the same. So for C, I have 122.355 seconds. Sorry, that's an S right there. That's an S for seconds. Then I look at my chart. 1 millisecond equals 0.001 seconds. So I'm going from seconds to milliseconds. So 0.001 seconds in 1 millisecond. So train track, take the top, divided by the bottom, and it's 122.355 milliseconds. And then for D, same idea, but just slightly different conversion. So for D, I have 122.355 seconds. And then here, we can say this is kilosecond is 1,000 seconds. So I'm going from seconds to kiloseconds. And there's 1,000 seconds in 1 kilosecond. So you take the top divided by the bottom, that's 0.122355 kiloseconds. So that's A through D. Any questions about that before I move on to the little more complicated E and F? All right, so if there are no questions, let's do E and F. So E and F is just slightly more complicated because now we are dealing with things with 2 units. So I have 2.554 milligrams per milliliter. So let's see how we deal with this on the train track, right? So E, 2.554. And before I put in units, I'm going to put in the track. Now, what I want you to think of as of this middle line, it's the same thing as a division line. So really, the top is a numerator. The bottom is your denominator. So the number 2.554 milligrams per milliliter, technically, you could write it out as 2.554 milligrams divided by 1 milliliter. That's actually what that unit means, right? Milligrams per milliliter means for every 2.554 milligrams I have 1 milliliter. In fact, if you remember from math, any number I could write with a 1 underneath it. So I could write 505 kilometers divided by 1. It would be silly to do that, but you could. So with this train track method, I have 2.554 milligrams for every 1 milliliter. And I want to convert from milligrams to milliliters to grams per liter. So let's start with grams, right? And we're in milligrams, so we want to go to grams. Just having my units there. Then my units cancel out. Milligram at the top, milligram on the bottom. I'm left with grams. And going to my table, for every 1 milligram I have, that's 0.001 grams. So that's from the table. And right now my unit is grams per milliliter. Now I don't want grams per milliliter. I want grams per liter. So I need to get rid of this milliliter. So if I have milliliter on the bottom, I need milliliter at the top and go to liters. Remember, if 1 unit's on the bottom and the other unit's on the top, they cancel out. And right now, when I do my math, my final answer will be in grams per liters. That's one of the great things about math once you get the hang of it. If you follow your units, you will never get the problem wrong as long as you do the conversions correctly, right? Any unit conversion problem, as long as you break it down in steps like this, you will always get the right answer if you put it in your calculator right, and that's a big if. All right, so milliliters to liters. For every 1 milliliter, that's 0.001 liters. So 0.001 liters is in 1 milliliters. You take the top, multiply it, divide it by what's on the bottom. And for E, you actually get the same answer out. It's 2.554 grams per liter. So 2.554 milligrams per milliliter is the same as 2.554 grams per liter. All right. Questions on the little more complicated E? And for F, going from kilometers a second to meters per second, you can follow the same logic. I'm not going to write it all out because I'm going to move on. But if you were to do that calculation, it's the same, 355 meters per millisecond. Now, it's not always going to work out like that. Like going from one unit to another is not always going to be the same answer. I've just set up these example problems to be like that. but just be aware moving on. That's not always going to be the case. Right. So any questions at all about our unit conversions, which I said this like on Wednesday last week, but I will just warn you right now. If you do not get this, we are going to do unit conversions this whole semester. Like these aren't going away. So if you don't get this, you're not going to get like this throughout the whole semester, and it's going to hurt. So let me know now through questions or email, or try the practice questions I have up online. Go to the SI session and get practice, because we use unit conversions a lot. All right, if there's no questions, I'll move on. And always remember, you can send me a private message if you don't want other people to see it. Where can I find this table in question 1 on Blackboard? That should be in class test 1 folder. You will find all of the slideshows I go over in class. This should be under 125, Jan 25th, problem set 2. All right, question 2 is another unit conversion problem, a fun one. I want you to calculate for me, how far is it from the Earth to the sun in kilometers if I give it to you in miles? And I give you what you need to know to convert from there. So I'm going to give everybody a couple minutes, see if you can convert from 92 million miles to kilometers. So question here. So converting from kilometers to decameters, you have 3 sections to the train track, but one is from seconds to milliseconds. There's only 2 sections on the train tracks. Well, technically, you could go directly from kilometers to decameters, but I don't know that conversion off the top of my head, and the table doesn't have that conversion either. The table does have the conversion from kilometers to meters to decameters, where 1 kilometer is 1,000 meters, and 1 meter is 10 decameters, or I think they have decameters, or I think they have it as 0.1 meter is 1 decameter. Same thing. That's why I did it in multiple steps for that. While on the seconds to milliseconds, that is directly in the chart. So I don't need to do any other conversion, because the chart will tell me there's 0.001 seconds in 1 millisecond. That's why I did one conversion in 2 steps and the other conversion in 1 step. Like I said, this can be a single step conversion if you want it to be. I'm always more comfortable going to the unit without the prefix in it to do it. All right, so I'm going to give everybody a minute or 2 to see if we can do this big conversion for us. And whoops, in case you don't have the table in front of you, there is actually one more conversion you need to know. There are 1,000 meters in 1 kilometer. So in case you're stuck, let's kind of work through this, right? So I start with the unit that I'm given. That's usually where I always start from. And for Gen Chem 1, that's usually a good place to start. Always start with what you're given. So I start with 92,955,807 miles. And I want to get to kilometers. So using the conversion here, let's just look at the logic. I start in mile, and from mile, I can go to feet. Then from feet, I can go from meters. And then from meters, I can go to kilometers. So that's the logical progression. Miles to feet to meters to kilometers. Start with miles at the top. I need to cancel out miles. And from my logic here, I'm going to go to feet. So I'm not going to put in numbers yet. I'm just going to put in my logic. Miles at the bottom, miles at the top, they cancel out. Now I'm in feet. I want to go to meters. So I cancel out feet, feet at the top, feet at the bottom, they cancel out. I go to meters. Now I'm in meters. I want to go to kilometers. So I have a meters at the top. So I want to cancel that out. I want to put meters at the bottom. And I end up with kilometers. So if I do all my calculations, my final unit will be kilometers. So let's put in the numbers. For every 1 mile, there's 5,280 feet. For every 1 foot, there's 0.3048 meters. For every 1,000 meters, there's 1 kilometer. Again, I'm just getting that from the conversions right in that problem. From there, you take everything at the top, you multiply it together, and you divide that by what's on the bottom. And I say, have this in 3 sig figs. We're going to talk about sig figs later. What three sig figs means is that your answer should have only 3 numbers. But like I said, we're going to get into sig figs way more in depth. So I need 3 numbers and then scientific notation. So it's 1.80 times 10 to the 8 kilometers. So is there any questions about that unit conversion? For the division part of the problem, do we divide by 1,000? Yeah, so what you're going to do is you're going to take this 92 million multiplied by 5280 multiplied by 0.3048 multiplied by 1 and hit enter on your calculator. Then divide that number by 1,000 because 1,000's on the denominator. Remember, this is like a giant fraction. These are your numerator. This is your denominator. You just have to multiply on the top, multiply that all together, divided by the bottom, all multiplied together. You got a different answer. So usually when people get different answers, it's calculator issues. It's possible I put it in wrong, but if you get a different answer, show me what you did on your calculator. I can see there. My money is going to be on order of operations of calculator, perhaps. Or I could have done it wrong. That's always a possibility. Wouldn't it be 1.49 times 10 to the 8? Well, let me do it right now. Let me do this calculation. If multiple people get the wrong or different answer than me, then it's usually I did something wrong. Usually I put it into my calculator differently. 208 times 0.3048. Looks like I did put it into my calculator differently. Yep, so it is 1.49. Even I make mistakes. So I must have put, I don't know, I just missed a digit somewhere. All right. I do want to show you question 3 really quick here, and then I'll let you go. So here we're doing a unit conversion, but we're doing it with density. So I'm going to do 3A really quick. So we have ethylene glycol, antifreeze, and it has a density of 1.11 grams per milliliters. Therefore, what is the weight in grams of 215 milliliters of ethylene glycol? Well, the way to do this is that we're going to treat this as a unit conversion where I put my density into the train tracks. So gram at the top, milliliter on the bottom. Then I multiply, and I'm going to put a 1 here because it's, remember, if it's a fraction like that, the denominator is always 1. Then I want to know what's the weight in grams if I have this many milliliters. Well, my final unit needs to be in grams. So I need to cancel out milliliters. And we've learned today that if I have a unit on the bottom, the way to cancel that out is put a unit at the top that's the same. So this unit is milliliters. So milliliters cancel out, and I'm left in grams. Well, what number do I put there? So 215. 215 milliliters. So I take my 1.11 and I multiply it by my 215. You get 239 grams. So question 3 is showing you ways that we can use these conversion factors, not just between converting units, but if we have like density, how we can use density to get different measurements. All right, so that is actually the end of our time here. So what I would like for you to try is try being C, see if you can figure that out. And I'll put the answer key to this PowerPoint online. If you want more practice with the metric system, I have about, I want to say like 20 problems up on Blackboard that will give you extra practice. And those problem sets are that answer key is also up. Feel free to email me. Feel free to attend Sarah's SI sessions, and we'll take it from there. Yes, Sarah just put her email up as well for our office hours. Yeah, with that, sorry for the technical problems of my computer freezing there for a bit. Otherwise, I will put a homework up, like always. Remember, your first homework's due on Friday. And every time we have a lecture, I'm going to put up a new homework, and that's due 1 week. So basically, you're going to have homework due every Monday, Wednesday, Friday this semester. So always be checking. That's under Tools Pearson, right? It will be mastering assignments. Otherwise, I have nothing left for you. So hope everybody has a good rest of their Monday. Take care, everybody.